Hello and welcome everyone. Thank you all for joining us today for this live stream event. Before we begin, I'd like to just quickly run through two items. Our code of conduct. So the Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but we ask that you're mindful of your commentary, remaining professional and on topic. This session is being streamed live to YouTube. It will be available for on-demand access in the next 48 to 72 hours. If you've not been on a live stream before through YouTube, you do need an account to interact in the chat. So if you don't have one of those, it's a good time to do it now. Otherwise, if you aren't able to get your questions answered while live, feel free to reach out to one of the Reactor event planners after. So today's session, we are joined again by Gwyn, our local cloud advocate, who will walk us through Introduction to Azure Kubernetes Service. I just tripped over those words there. Sorry, everybody. Intro to Azure Kubernetes Service. This is the last session of a series of sessions that were focused on Linux. This session will run for approximately an hour with time for questions throughout. So at this time, I will pull up our wonderful speaker. Hello, Gwyn. Welcome, welcome.
Hi, Rebecca. How are you?
I'm good. I'm going to switch over to your slide because it just looks so much cooler.
Oh, thank you.
Is that cool? That's so fun.
Awesome. Yeah, Kubernetes, for someone who hasn't been saying it for like a lot lately, it's kind of like a word that you can easily trip on. There's a lot.
I prefer, let's just go AKS.
I like that. I like that.
Yeah.
Right. But yes, hi everyone. Hello chat. So we got a couple of people checking in already. Had some messages posted in there from hours ago. So it's exciting to see how excited people are about this specific topic. But hello, yes, my name is Gwen. I'm here, but my picture is also on screen. Yeah, I'm a cloud advocate here at Microsoft, and today, like Rebecca mentioned, we have the last session going on this Linux focused month. We've done, we did a bash session. We did a Terraform, so infrastructure as code session. We did a container and Docker session last week, and today we're finishing off, rounding it out, closing it out with Kubernetes and an introduction to Azure Kubernetes Service, right? So cool. Let's dive right in. At any point, feel free to ask questions in the chat. Y'all know how this works. And then my socials, there's my handle, my Twitter handle there. You can ask me at any time. Questions after the session. I'll try to incorporate them throughout, but if not, I'll get to them towards the end. All right. Cool. We have a GitHub. Rebecca will be dropping links throughout the entire session. We have a GitHub. The slides are there. Some links for you to do additional learning will also be available to you there. So if you're, say, studying for a certification, I think the AZ, probably the 204, potentially the 304, have some AKS related things. So they could potentially be useful as notes or something like that. But yeah, grab yourself a copy of these slides at that GitHub link. Alrighty. So let's talk about what happened here. Hold on, there we go. Okay, cool. So what's on the agenda for today? We've got some concepts to cover. What is a container management? What is Kubernetes? Kubernetes components, Kubernetes manifest files. Then we're going to dive into some Azure Kubernetes Service, how AKS works. AKS is short for Azure Kubernetes Service. AKS clusters, application routing, when to use AKS. Finally, we're going to have a demo that is deploying an AKS cluster using the Azure CLI in 5 minutes. It's probably going to take more than 5 minutes because I'm going to take my sweet time explaining things. But it makes for a great title, right? Alrighty. And look, I've been putting in a lot of work with my slides to try to make them look more like fun. Look at this illustration. I didn't make this. I found it. We have like a bunch of these pre-made illustrations, but it's awesome. It's our mascot, whose name is Bit, with the Kubernetes mascot. Very cute, right? So anyway, let's get started with the concepts. First up, we have what is a container. So sort of like a general overview of Kubernetes. You have Kubernetes, which is container management, container orchestration. But to even sort of start to understand or start to learn about what container management is, you need to understand what a container is. And we did a whole session on containers, a whole hour session, did a deep dive into them last week. So be sure to check those out. The recordings are available on YouTube. So a container is a standard package of software that bundles an application's code together with the related configuration files and libraries and with the dependencies required for the app to run. So in, I guess, a more simplified definition, a container is grabbing the code of your app and everything that it needs to run, packaging it up together in an image, and then when you run it, it's a container, right? Containers are meant to be highly focused specific services. So they're not meant to do multiple things. Really, like when you think of the concept of like microservices, where you have one service doing a very specific thing, those are where like containers really do shine, right? Okay. So what is container management? Container management is the automation of deploying, updating, monitoring, removing, and scaling containers efficiently and with little to no downtime. Now, when you think of containers, you can and you have this concept of like you'll have sort of a service per container. It could be pretty, I guess, easy to do all these kinds of tasks in terms of management with individual containers, maybe even a few, probably not, but perhaps. But when you think of like, having several services, several containers, that's where things start to get very, very messy. Like, let's think you're trying to update the version of some sort of app. How do you make sure you're updating like to the right version? You're updating all the containers that you need to update. How do you make sure you're getting rid of the older versions? Things like that, right? So this is where something like a container management orchestrator comes into play. And finally, Kubernetes. What is Kubernetes? So Kubernetes is an open source software for deploying and managing containers at scale. And it's also the Greek word for helmsman of a ship or pilot. And it's sometimes referred to as, you'll see this K8S, right? So this right here, or K8s. And the 8 stands for the amount of letters between the K and the S. So it's abbreviated that way. Now, if you think of sort of going back to the session that we did last week, we did containers and Docker. Docker being most likely the most popular container platform out there. Kubernetes is essentially the most popular orchestrator container management platform out there. I'm not saying it's the best. I'm not saying it's the one you should use. I'm just saying it's the most popular one out there. One of the most popular ones out there. There are alternatives. But given that it's the most popular, I figured it'd be the most useful one to go through today. Okay, cool. We've got some definitions done. Someone asked for the PowerPoint that I'm running, GitHub link that we dropped in the chat. It's uploaded to GitHub, so you'll have that there. Okay, cool. Let's dive into some Kubernetes components. So let's try to like step into this from like high level. So when you think of a Kubernetes deployment, it's actually a cluster. So the deployment is known as a cluster. So everything that lives inside of your Kubernetes deployment is known as being inside of your cluster, because Kubernetes is a cluster-based orchestrator. So instead of having a single machine, and when we talk about sort of cloud-hosted, cloud-based Kubernetes, we're always going to be talking about virtual machines. Now, don't get me wrong, you can use Kubernetes on-prem, hybrid, whatever sort of infrastructure you have going on. But since we're talking in the context of cloud, you're going to be working with virtual machines, right? So instead of having a single virtual machine, it'll use several virtual machines working as one. So that's the magic of a Kubernetes. It'll grab a bunch of machines and it'll make it work as one. And these are known as nodes. And again, they can be virtual or physical. So we step into our cluster. Again, we've got a cluster. Then we find our nodes. And nodes can be of two types. Well, I guess one of two types, right? Nodes are where your workloads are deployed. So where your apps are deployed, your services are deployed, anything, I guess, user created, as in you, developer created, will be on your nodes. Then you have control plane nodes. These are the nodes that work to manage your other nodes and your other pods and your other like sort of services that you need to manage your nodes that have your workloads deployed on them. Things like API, things like your scheduler, things like that, right? So remember, two types, right? Okay, so we've got our Kubernetes cluster, sort of the overview, high level. And then we've stepped into it. We have nodes, and we know we have two types of nodes. And so what do we have inside of these nodes? Good question. So each node will have one or more pods. A pod is a group of one or more containers. Remember, containers. With shared storage and network resources and a specification for how to run the containers. And there are also the smallest deployable units of computing in Kubernetes. So there's nothing more granular than the actual pod. Like you can't deploy anything smaller than that. That's like the smallest unit possible in Kubernetes. Okay, so again, Kubernetes deployment is a cluster. Inside of a cluster, we're going to find nodes. Nodes can be either nodes or control plane nodes. And then inside of each node, we're going to have pods. And then inside of the pods, you have containers, multiple containers, one or more. But you can't simply deploy a container. You would deploy a pod, right? Okay, cool. I have here a diagram to sort of explain this a little bit more. So we have a Kubernetes cluster. And we see we have this blue dash here, right? This dashed line here. And this is sort of outlining the nodes that we're utilizing for our control plane. So you can see we have API here, we have a scheduler, all these kinds of services that we need to manage our worker nodes here. You see on our worker nodes, we have a kubelet, and then we have a kproxy. And again, our worker nodes need to be able to tell our control plane the status of the pods that are inside of the nodes, if they're working, like all those kinds of things. And that's what the kubelet is there for. And then the kproxy is to enable networking. We'll talk a little bit about networking later on, right? And then over here, we see we have a cloud provider API. So given this is a sort of cloud-based Kubernetes, here you'd have something like AWS, Azure, GCP, IBM. All of these cloud platforms have ways of hosting Kubernetes and have services, right? I think, so you have Azure Kubernetes Service. I think the Google one is Google Kubernetes Engine or something like that. Then you have serverless Kubernetes, like Azure has Azure Container Apps. I know Google has Google Cloud Run, I believe. Yeah, bunch of cloud-based Kubernetes services these days. Okay, so that's essentially a high overview of how, like, in our Kubernetes architecture would be structured. Okay, a few more things about Kubernetes. Now, if your application can run in a container, it can run in Kubernetes, right? That's essentially the only, I guess, rule you have to follow. Kubernetes is not specific to a type of task, a type of program, a type of application. No. Anything that can run in container can run with Kubernetes or can be orchestrated by Kubernetes, right? Also, Kubernetes is not a single application that is installed. It's not like a .exe or a what's the Mac OS one, DMG, right? It's not like something you just double click, you got a wizard installed, perfect, it's running for you. Absolutely not. It'd be great if it was that easy, but it's not. You're responsible for finding the best solution that fits your needs to address your deployment, scaling, load balancing, logging, and monitoring. It's extremely flexible, which is great, but also it means like there's a lot that's up to you to figure out. And Kubernetes doesn't provide middleware, data processing frameworks, databases, caches, or cluster storage systems. That means no, Kubernetes doesn't have built-in like persistent storage or anything like that. All of these, you have to run them as containers inside of your cluster or part of like a third-party service. For example, with Azure, you can use Azure Storage to become storage for your nodes and such, but it's not built in. All right, so keep that in mind. Cool. Next up, I want to talk to you about Kubernetes manifest files. So I like using analogies with containers and because, you know, again, Kubernetes is container orchestration, right? And when you're creating a container, you have, well, for the example of using Docker, you have a Docker file, right? Your Docker file is a text file with instructions essentially how to build your image, build your container. Kubernetes has something called a manifest file, which allows you to describe your workloads in the YAML format declaratively. Manifest files contain all the information that's needed to create and manage the described workload, and the structure of the manifest file differs depending on the type of resource that you create. I have an example here, but towards the end when we get to the demo, we'll also have another large example that we can take a look at. But again, just keep in mind, manifest files will describe your cluster, everything that gets deployed in your cluster, all that kind of stuff, right? Cool. Okay, now we can dive into Azure Kubernetes Service. I wanted to sort of just give you a high-level concepts of Kubernetes. That way, when we dive into AKS, it's not like complete foreign concept. Cool. All right. So what is Azure Kubernetes Service? So AKS for short. I'm going to just call AKS now. It's shorter. Manages your hosted Kubernetes environment inside of Azure. Its features include automated updates, self-healing, and easy scaling, and a few other things. Those are sort of like the highlights. The Kubernetes Cluster Master, also known as the control plane, is managed by Azure and is free. And you only pay for the VMs on which your nodes run. So remember we were talking about the two types of nodes. You have the control plane nodes that manage all your worker nodes, and then you have your worker nodes. You're not paying for the nodes that run your. You're only paying for the ones that run your, where your nodes are deployed. You only pay for those. Okay. AKS aims to give you the benefit of open source Kubernetes without the complexity or operational overhead compared to running your own custom Kubernetes cluster. Can you containers here? Thanks. Yeah, if we could drop the link to container recording that we did last week, that'd be great. We'll get that to you at some point in the chat. But thank you for asking that. Okay, cool. Yeah. All right. So that's a brief overview of AKS. Oh goodness, I went back. My bad. Look at what I did. I'm using a different keyboard that I'm not used to, so I hit the wrong button. Where were we at? Custom compared to running your own custom. Okay, cool. Don't get me wrong. There will be times where you're gonna have to have a custom Kubernetes setup. I'm assuming that if you're just like this absolute massive company, like something like, I don't know, Netflix, and you're just deploying containers and orchestration changes every like 30 seconds, you'll have to an extent a custom Kubernetes setup and completely fine. But there are many use cases where having something like cloud hosted Kubernetes would fit you well, right? So at its core, an AKS cluster is a cloud-based Kubernetes cluster. So when I say AKS cluster, just remember it's a Kubernetes cluster. It's just in Azure, right? You can use kubectl, kube control. If you've worked with Kubernetes before, you know kube control is essentially the command line that you use to work with your Kubernetes clusters. Or the Azure CLI to manage your deployments. We're actually going to use the Azure CLI in a demo at the end for this. AKS supports all popular development and management tools: Helm, Draft, Kubernetes extension for VS Code, Visual Studio Kubernetes tools. And another cool thing is this thing called Bridge to Kubernetes, which allows you to have end-to-end local development and testing with other components in your AKS cluster. So the reason I added these last 3 bullet points in here was when you think of the context of a migration, if you can use the tools that you are used to using in your on-prem or your hybrid, whatever scenario you're migrating from, it's going to be a lot easier and efficient, I would say, for you to move into using something like cloud-based Kubernetes, right? But it's great to know that these are also available for us, right? Okay, cool. Now, when we talk about configuring an AKS cluster, again, AKS cluster is a cloud-based Kubernetes cluster. There are a couple of things that we have to define up in the beginning, right? One of them is node pools. Node pools are used to group nodes in your AKS cluster. You specify the VM size and the OS type for each node in the node pool based on your app requirements. Node pools are essentially VM scale sets. If you worked with infrastructure in Azure, you're most likely familiar with VM scale sets enabling you to scale your virtual machines. And you have to set like minimum, maximum, all those kinds of things. So under the hood, AKS node pools are scale sets. So it's, I guess, a little fun fact for you. Now, each node pool will have a mode that you have to set. And this is sort of pairs along with, remember I was telling you nodes have the control plane or your work node, right? And AKS, their system node pools essentially would be control plane nodes, and then you have user node pools, which would be the regular worker nodes. System node pools, again, serve the primary purpose of hosting critical system pods. I guess critical is the right word to there. But yeah, again, your scheduler, your API, those things, right? And then your user node pools would be your worker nodes, right? So by default, an AKS cluster will have a Linux node pool in system mode, but you can always add more. If you think about this, this makes complete sense because you can't have an AKS cluster without a control plane. And Linux is just the most popular option in terms of like an operating system for your servers when you think cloud. So it makes sense to have a default be Linux node pool in system, right? And then do keep in mind that new created in the node pool will always be the same size as specified when you create the node pool, right? And this makes sense because, again, it's a scale set, right? You wouldn't want to have a node pool defined for, again, because when you're organizing these and structuring out your architecture, you're creating nodes with something in mind. Like you're creating it thinking of oh, I have this app and I have these requirements and it needs this size VM to run efficiently and this operating system to run efficiently. Why would you randomly throw in thinking Ubuntu something? I don't know what the latest one is. Of size, I don't know. DS version 2. Why would you throw in some Windows Server one randomly in there? You could, but you'd probably be better off putting that in a node pool that has that specific, right? And then kind of pairing them. Just a thought. Okay, cool. Continuing with configuring an AKS cluster is the node count. The node count is the number of nodes your cluster will have in a node pool. Pretty straightforward. And then you can change the node count later in the cluster's configuration panel. But do keep in mind that it's best practice to keep this number as low as possible to avoid unnecessary costs and unused compute power. All right. On the right side, we have a diagram here showing us that it looks like we have 2 node pools in this. So we've got NC24S v2 standard node pool with that type. And then it looks like we have B2S standard, of course, and the other one. So I'm assuming that the top one would be our control plane and that bottom one would be our worker nodes or something like that. Cool. This last thing that I put in here, best practice to keep this number as low as possible to avoid unnecessary costs and unused compute power. Remember at the beginning, I was sort of talking about this concept of serverless Kubernetes. If you have, or serverless Kubernetes or serverless container, things like that. If you have let's think of a workflow that works great in a serverless context. So remember, if you have something that works sort of in bursts, or you don't need to persist state. If it's something that doesn't run, if it runs a couple of times a day for a certain amount of time, and the rest of the time it can be completely off, something like serverless would be a great thing for you to take a look at, because you're probably going to save a lot of money. Again, I mean, if your workload is something more of it needs to run 20 hours a day, serverless is probably not the best for you. But if you're trying to look for ways to save money, you can fit your workload into sort of serverless contexts. You'll have container apps, right? Or Azure Container Apps, right? Just a thought there. AKS application routing. So this is also part of configuring an AKS cluster, but I think it's actually pretty neat. I wanted to add it in here. And this isn't something you have to enable. You absolutely have to enable. It's an add-on that you could later configure for your AKS cluster. But when we think of networking, I was talking about this, I think talking about networking a little bit, but a Kubernetes cluster, so your entire deployment blocks all external communication by default. And when you sort of try to think about why this is, it makes a lot of sense. So we can take it at the most, the smallest deployable computing unit, which is a pod. A pod has several containers inside of it. And when you think of the life cycle of containers compared to something like a life cycle of a virtual machine, when it comes to networking, they're very different, right? Because a container, you're meant to destroy, update, redeploy, rebuild, all these kinds of things. Whereas virtual machines, you're kind of expecting them to be around for longer. The life cycle is longer for them. So it makes sense to attach an IP. You could attach an IP directly to a VM, and then you set it, and it's good. But containers, if you're destroying it, that means your networking configuration would also leave. And then you'd have to be oh, constantly reconfigure this, right? And that goes to the container level, pod level, node level, all these kinds of things, right? And as you move up, it's okay, so what do I do with my cluster? But Kubernetes has 2 network availability abstractions called services and ingresses, right? A service acts as a load balancer and will redirect traffic to specific ports by port of here. So we have cluster IP, which is this top right diagram. So if you just need your pods or your services in the inside of your cluster to talk with other services in the inside, you could use cluster IP. If you needed your services to work with external things, traffic, you'd use node port. Load balancer exposes the app externally by using Azure's load balancing solution. And then external name maps the app by using a DNS resolution through a CNAME. So those are the types of services that you could use. And we see we have examples on the right side here. Now we have an ingress, because remember I said there's two network abstractions, services and ingress. An ingress will expose routes. Essentially, it's a collection of rules, right? For HTTP and HTTPS traffic from outside a cluster to services inside the cluster. And you define ingress routes by using ingress rules. Again, none of this is like enabled by default, right? The tricky thing comes like, okay, you can sort of try to, if we take a step back, I'm going to take a pause. Someone's saying like the video shot. Is that for everyone, or is that just on LinkedIn, YouTube, Twitch? Can you let me know if the video is fine before I keep? Hopefully it's good. I'm not seeing any errors on my end, but hopefully it's good there. Just let me know in the chat. Okay. All right. Cool. Okay. So what I was trying to say here about networking is like you can sort of figure out when to use cluster IP, when to use node pert, right? Completely fine, right? But when we go to, let's take a look here. When we go to like figuring out, okay, external networking, it's like, okay, I can use a load balancer, or I use an ingress. Load balancer might be a little bit more easier to set up, but an ingress will have more features, things like that, right? So it's like you have like a lot of like issues on like trying to figure out like which solution to use, right? So AKS allows you to overcome the complexity of setting up an ingress by enabling what's called HTTP application routing. And this add-on makes it easy to access applications on the cluster through an automatically deployed ingress controller. Essentially, this add-on will deploy an ingress controller that's configured for you, and then you'll have all your DNS mappings and records and such that you need to access your services externally, right? I'm going to take a pause here. Audio dropping on YouTube as well as video and low. Interesting. Let me take a look. Give me a second here. Just to take a quick pause.
Hey, Gwen. On our end, it's not really like whole sections of your conversation. It'll just be slightly like a little, like your one word will kind of sound a little glitchy, and then it's just normal talking again as far as what I'm seeing. It's not like affecting the overall content, I think, that's being conveyed.
Oh, whoa, my thing just like refreshed.
And your presentation's coming in fine. Yeah. Okay.
So is it like you can hear it still? Like we can power through it?
Yeah, I guess the audience can let us know too, but I think overall everything you're saying is coming through. Just one word out of every 10 maybe like chops a little bit. And your presentation's coming through clear, at least on this end. It might just be buffering since there's a few channels. Martin approves.
Sound is fine. Sound is fine. Okay, I'm gonna keep trying to like go through it. Hopefully it'll fix itself. Man, I've been having some maybe it's stream error. I don't know. But I've been having like no issues today with it. So all right. Anyway, we'll keep going. Cool. Where were we? Okay, yes. So again, we're talking about ingresses, services. When you're trying to figure out like, well, which one do I use? AKS has this feature called HTTP application routing that you can enable. It's not enabled by default, and you don't have to enable it, but it is a nice add-on that helps sort of overcome this complexity. Okay, cool. What happened here? Again, here we have a little diagram. So again, if you're trying to access the internet via your services, can't do it. But once you have an ingress set up, you can do it, right? Cool. So some little, I guess, tidbits on when to use AKS. And you've got your sort of obvious ones. If you're using Azure Active Directory for identity and security management, it's pretty easy to set up AKS in your cluster to have access to identities and group membership. AKS can use Azure Monitor, so you can have integrated logging and monitor. You have outer cluster node and pod scaling. Cluster node upgrades, which is managed, you don't have to worry about. GPU enabled nodes. So if you have a graphic intensive workload on a working node and you need to have a GPU enabled image, or as in virtual machine image, that's supported in AKS. You can use Azure storage. to attach, reattach storage volumes to your nodes, and you can actually schedule these apparently too. Yeah, you have virtual network support, so you can incorporate your AKS cluster into your existing VNets. And with VNets, you have on-prem, you have hybrid, you have strictly in the cloud, right? So whatever your setup is, you can incorporate your AKS cluster into that, and then potentially have a cloud-based hybrid sort of kind of thing. Pretty interesting. Ingress with HTTP application routing support. We talked about that feature there. And then, of course, Docker image support and private container registry. So there's a couple of examples of when to use AKS. All right, cool. I think I have one more slide here. And if you want to learn more, I've added some links into this slide. These where you have introduction to AKS, deploy an AKS cluster with Azure CLI, and then deploy a containerized application on AKS. So I sort of added them in terms of like the amount of time and difficulty. That first one is just concepts, just theory. That second one is actually the exercise that we're going to run through today. And then that last one is deploy a containerized application on AKS. This will probably take you a little longer. It's still hands-on. It'll probably take you about like 2 hours or so to get through. But it's great. Great concept to upskill on. So keep that in mind. All right, cool. Let me switch to full camera here. And we're going to go to, let me close this thing here. 1 second. Let me open up everything that I need to open up. And then we can go from there. So we're going to be following let me go this way. One of the links that is in the PDF. Let me just open it up first. I'll have my portal open and go full size here. Okay, cool. And I'm going to open up a Cloud Shell before I share my screen again, just so everything is ready to go. We'll open this up here. Okay, let me bring my screen up again, and we'll do this here. Cool. I think that's a decent size. Yeah, so this says it's going to take 6 minutes or 5 minutes, but I know it's going to take longer than that. All right, cool. What time are we at? Plenty of time. Love it. Is the text size large enough here? Text size, we'll probably do a few more here, and then maybe like a few more here. I think that's pretty good. What do people think about that size here? So essentially what we're going to be deploying here is we're going to deploy an AKS cluster using the Azure CLI. And it has a web frontend. So I think there's 2 containers in this one. So we have a web frontend and a Redis instance. And the cluster, if you're not familiar with Redis, it's really great for like caching and querying and things like that. And then we're also going to monitor the health of cluster and pods that run your application. And we're going to be deploying this Azure voting app where you can vote if cats or dogs are better. Yeah, so cool. This sort of prereq here, this tutorial, has a lot of information, a lot of links. Highly recommend you go through it. Because you know what, I was going through this earlier, and I saw that they even have like a link to how you can run the Azure CLI in a Docker container, which I think is pretty important for people to know. But I'm going to do this in a Cloud Shell. But again, you have the option, right? So you have some prereqs to go through, so be sure to check that out too. And we're gonna get started. I need to create a resource group apparently first. So I also did a full session on using the Azure CLI back in, I think it was October. Maybe you can go on my channel and find those. So this concept of creating resource groups, VNets, all these kinds of things with the CLI, I covered already. So we're gonna do AZ group create, and I'm just gonna try to follow like the same variables that they're using. They're calling it a my resource. It's a capital, my resource group. I'm going to type them and then explain the command just so they have time to run as I'm explaining. And we're doing East US. Pretty simple here. All right, we created our group. And now it's telling us to create an AKS cluster. So I'm going to go ahead and AKS create. Resource group is my resource, capital there, resource group. And then the name is going to be my AKS cluster, AKS cluster. Come on. The worst time to change your keyboard is absolutely when you're doing a demo. And then we have our node count. Node count is going to be 1. And then for add-ons, we're going to enable add-ons. We're going to enable monitoring. And then it's telling us to generate SSH keys. Generate SSH keys. I think that's everything. Let's type that in, and then we'll step through the command itself to do, right? Okay, so I just want to make sure it's fine, it's working, and I don't have any errors. All right, cool. So essentially it's telling us AZ. If you haven't worked with the Azure CLI, every command will start with AZ. And then if following the service that you want to work with, if you want to work with groups, it'll be groups. If you want to work with virtual machines, it'll be VMs. If you want to work with, I think if you want to work with like your subscriptions and counts and things like that, it'll be accounts. So in this case, it's AKS, right? Then it's the subcommand and then each service will have different subcommands. Again, you can access this with a -- help. And it's telling us, all right, which resource group are we putting it inside of? And we're doing it inside of the my resource group, which we created above here. Then we just provide the name of the cluster and then the node count. We just need one in this example, so we're not like deploying anything crazy. In terms of add-ons, so with the concept of add-ons is like if you need like storage, if you need the HTTP application routing that I was telling you, or in this case monitoring, you would define it here. And then we're using the -- generate SSH keys, which will allow us to VM or not to SSH into our nodes via the CLI, right? So because it's essentially going to generate an SSH key pair for us, with one of the keys being inside of the Cloud Shell, right? Apparently this takes a couple of minutes, so we'll see. What else did I want to show y'all around here before, as we wait? How is the audio and all that stuff going? Pretty well. Can we set up AKS with an Azure free account? I'm pretty sure you can. I'm not 100% sure. With the free account, as in like you don't want to pay anything, or like do you want to use like a free tier? Like depends on what you're asking for. But I don't think there's any restrictions in terms of like what you can deploy, right? Alrighty, cool. We got this. So the neat thing about let me open up another tab on my portal, and we'll see if this is getting generated. So I provided a name for a resource group, but when you're deploying AKS, it actually deploys an additional resource group for you. Let me close this one. We're using this subscription here. So we're creating this one here. So this is my resource group, right? This is the one we created, we defined in the Cloud Shell. And you can see in here, we only have Azure Kubernetes Service in here. The actual resource for the Kubernetes service is in here. But you saw that from that list, we also have this, my resource group, my AKS cluster. And this sort of naming convention was provided by the actual like Kubernetes service. It does it. You can also provide an own resource group and tell it to deploy its infrastructure in your own resource group. But you need two, right? So in here, we'll see we have a public IP address. Let me make this here. A public IP address. It looks like we have a network security group. We have a route table. We have a virtual machine scale set. We have a VNet. We have a load balancer, managed identity, all these kinds of things. Okay, cool. Someone said, whatever you twiddled with the audio video streaming made all the difference, by the way. Okay, cool. I'm guessing it's better. I hope so. I didn't do anything, but I'll take all the credit. Okay, cool. So this is something important to keep in mind. You'll have one resource group for just the Kubernetes service, right? And then you'll have one for all the actual infrastructure for the Kubernetes service, right? So let's go back to that other one. And inside here, it's still deploying. So I'm assuming that it's not fully, like it doesn't fully have like all the things that we can look into it. It might, let me see. Nothing in here yet. It's still being created, but remember I told you we have services and ingress. You can take a look at them here. Storage, configure in here. Additional configurations, like things you want to add on to, and secrets and stuff will be here. Our node pools will also appear here. And let's see, cluster configuration, all these kinds of things are in here too. I think you have upgrade. You can upgrade from here. So this service thing, this control plane, again, remember for your control plane nodes, you don't pay, you only pay for your worker nodes. Okay, cool. So this is still running. Hopefully it doesn't take too much longer because then I know we have to go and connect to it, and then we have an actual manifest file that we're going to use. There we go. I was going to show you the manifest file, but we can step through that as we go. Okay, cool. Oh, look at that, free tier. So it looks like you can. Let me see here. Okay, cool. So look, so for whoever was asking, is there a free tier? Yes, it looks like there's a free tier here for something. For our, let's take a look at it. Node resource load, but well, for one of these network, it's kind of hard to see in our Cloud Shell. But yes, different services potentially can have a free tier there. Okay, cool. So now it's telling us, oh, so if you're not using the Cloud Shell, you're going to need to install AKS, which is the kube control within Azure. But since we're using Cloud Shell, we already have it installed already. So I can just copy this to save some time. Because I named my resource group and my cluster the same thing as the tutorial. Fantastic. We'll say yes here. Different object name can already exist in your kube info. I guess we can put yes. Do I already have something here? Ah, you know what? Let me remove this here. ls clear. Fantastic. CD cloud drive. What's in this? Ah, nothing, I guess. Okay, cool. Clear this up here. All right, so we are connected to our AKS, and it says now that you can verify the connection to your cluster using the kube control get command. Fantastic. So if I do kube ctl get nodes, it should show us just one because we deployed our used that AKS command with just node count 1. And there it is. Fantastic. Cool. So now we actually get to run the application, or I guess deploy it. It tells us now that we need to use a YAML file that will have our Kubernetes manifest. And it gives us the option to use code, Vim, or Nano. Ha! I didn't know that you could actually use code in the Cloud Shell, but we're gonna use Vim for this. Every time I ask the chat, so if we should Vim or Nano, it's quite an interesting amount of messages, and people have their opinions on this. But last time we used Nano, so this time we're gonna use Vim. So we're gonna create this vote.yaml to start describing what we want for our Kubernetes cluster, right? I'm gonna copy this, and then we can just step through it. Because it's quite a lot, right? So what do we have here? So since we're deploying two containers, essentially 2 services, we'll have, if we look at this, I'm going to try to make this just a little smaller because it's easier to see when it is smaller. So we see here we have Azure Vote Back, and then we go down here, and we have Azure Vote Front, right? So essentially this half up here is describing what we're using in the back, which is a Redis instance. And we describe a lot in here, but I guess the biggest parts is like, okay, which image are we creating this container from? And a couple of other things and metadata and such like that. And then we have port. I have that port open there. Now with our front, the front end is what we actually need to be able to access. So the configuration is going to be, again, you have like where you're pulling your image from, and we're using a MCR, which is Microsoft's container registry. I guess it's their private one. And then here, the difference is when we're trying to tell what kind of service it is, it's a load balancer, which is up here. We don't have, where are we? Where did it go? We don't have that here, right? Because load balancer, again, remember when we were talking about the types of services, it doesn't have, like, it will allow for external traffic, right? Whereas our backend, we don't need anything to access it externally, so we don't provide anything. Okay, cool. So we've created this file, and how do I escape again? I think it's just like this, right? There we go. Cool. So let me just cat the output of that to make sure it's actually there. Azure, it's all there. Cool. All right, cool. So now we can do just kube control apply, and then we're going to provide the name of the YAML file. And let's see what happens. Okay, so I don't trust that. That was way too quick. Output shows successfully created deployments and services. Okay, so it says it was created. The Kubernetes service exposed the application front end to the internet. This process can take a few minutes to complete. Okay, so now we have to use a monitoring command. So now it's telling us kubectl get service Azure Vote front, and then it's going to ask us to watch. So this is going to actually tap into. So remember when we did the AZ AKS create, and then we did -- enable add-ons as an option, and then we provided monitoring. So this is going to provide us monitoring to this specific service that is called Azure Vote Front, and we know it's called that because that's the name that we gave it to here, right, in our YAML. but it's already giving me an external IP address. I don't know why it says it takes a few minutes. Here it says it's going to be pending, but in ours, we already have it. I think it would probably be like this one, Azure Ports Age, like this one here. So if I grab this and then paste it in here, we'll see if it works. Ah, it did work. Look at that. Dogs are better than cats. Cool. So what does this tell us here? External changes from Azure voting apps. Delete the cluster. Yeah, wow. That was actually relatively quick. I thought it was going to take a lot longer, but hey, it's nice to be surprised. So let's take a look at the, where is our actual infrastructure resource group? Here we go. And let's see what kind of things have been updated here. Where is our, no, you know what I'm looking at? I'm looking at the wrong one. I'm looking at this one here. So our AKS cluster, we click into that. So now we should probably see a lot of things have been like loaded because it's actually been created, right? We have our namespaces in here. We've got our workloads, and we can see we have a namespace queue system. And then the ones that we deployed is in like user, is this Azure Vote, back and Vote front. Already up to date, available, and the age. That's pretty neat. Services and ingress. If we close this off here, we'll see. And then you know what's pretty neat to do here? We do show labels. We have Kube DNS, Kube system. We have our Azure Vote back, which is set to cluster IP. Remember in our manifest, we didn't put that it was a load balancer because it just needs to be internal communication. Right. Only the backend only needs to talk to the front end, but internally. So that's why it's set to cluster IP. Because remember in the slides, we talked about cluster IP would be set if you just need your pods to talk to internally. And it looks like we have a couple more details in here too. And then our Azure Vote front is utilizing load balancer. And this is just IP. Like if you need to configure DNS, you would have to use HTTP application routing. But out of the scope for this video, maybe if we did like an intermediate AKS sort of version or session, we could talk about that. But it's pretty neat. That's in here. Let's see what else is here that's actually potentially interesting. Monitoring, this is all pretty standard with like additional Azure resources that you would use, and you're probably familiar if you've used Azure before. Where did I go? Wrong one. Node pools, GitOps preview. AKS can be configured with Azure DevOps pipelines, GitHub Actions, and things like that. That would be an actually great session idea to get this into a CI/CD pipeline. But that is actually, let me see what else do we have here. Networking, got a bunch of cool things here. But anyway, I want to wrap this up so I can answer y'all's questions. I do apologize for the video issues here, but let's go back to full screen. You know what? I probably have to stop this here for a second, and then we can. What is the wrong? There we go. Why is it? There we go. Easy group delete because I don't want to rack up bills. The name is what's the name of this? My resource group. You sure? Yes, I'm absolutely sure. Okay, cool. Now we can go back to full screen here and take a look at all the questions that people have. Let me see here. People are saying, I always like asking the Vim versus Nano versus code kind of question. It's interesting to see what people would say. Let's see here. Can we define that second resource group name, or has to take the default automated one? No, you can define. You can provide whichever naming you want to for that second one. It'll just default to whatever naming convention it utilizes, which it looks like it's just that underscore usage there. Let me take a look at this. More questions here. We've asked her, yeah, free account. Yes. Hold on. We're going down here. Another great session. Absolutely. Thank you. What do we have a question here? Kubernetes or CNI? Hold on. Give me a second. I need to rearrange my windows because I'm just verifying that it is actually deleted for me, because if not, it's going to rack up some bills here. Okay, awesome. I don't know what this question is referring to. This one right here. If you could clarify a little bit more, that'd be great. Let's see here. AKS is Kubernetes as a service. Azure Ranch is more like a management tool that's in some new versions, including AKS cluster created by the Rancher team. There we go. I love it when the chat answers the questions. What else have we got here? Let's take a look. I got a starred message. Oh, we answered that one already. You can use code dot. Cool. In the CLI, you can actually use code dot. I didn't know that. I mean, in the Cloud Shell. I know you can do it locally. I didn't know that you could do it in the Cloud Shell. Very cool. What happens to apps when a cluster is upgrading? What happens to apps when a cluster is upgrading? So you'll have to like essentially plan for downtime or how you want to do this, right? And you'll have to understand how you want to like manage like previous versions as well. But when you're upgrading, you'll have to also think about like sort of staging them in a way where it's like, if you have just one instance of your app, right, and you're going to go update it, then your app is going to be offline while it's updating, right? But like Kubernetes itself won't like eliminate downtime. You still have to like plan for that, if that makes any sense, right? I think we got all the questions here. We have anything else to share, Rebecca? We're right about at the end of it. But if anyone has more questions, feel free to add them in the chat. We can continue answering them.
Yeah, so just a quick plug. I dropped in the chat a link to our survey. We always like to learn more about our audience. The content that we put out is curated for you. So let us know a little bit about your experience level, background. We're targeting, free content for your level of learning. So the more we know, the better prepared we are. And just enter the event code 15161 for that. If you are tuning in from one of the various channels that we are streaming to, just to note, this session is brought to you by the Microsoft Reactor. I feel like a commercial, the Microsoft Reactor. If you're not familiar with it, it is free community programming. We put sessions on all the time. We're an international program with 12 physical spaces. So we have sessions happening at all hours, depending on where you're tuning in from. If you're not familiar with it, you can find us on Microsoft Reactor's meetup pages. Find the location closest to you for all that virtual content. You can find us on Twitter. We have a newsletter, aka.ms/reactor email sign up. We send out one email once a month, just with anything that we have on the calendar coming up for the following. So check us out. Follow along. Any questions that came in? I think a couple.
I just wanted to add that if you speak Spanish, we're doing this exact session on Thursday at the same time, 5 Eastern, right? Or 6 Eastern. 6 Eastern.
6.
Sorry.
Yes.
So same content, but in Spanish. So if you speak Spanish, you want to see it in that language, fantastic. Or maybe you want to learn Spanish, that'd be awesome too. Let me take a look. I think there was one question here that I could answer here. How would you connect backend containers with a pod and manifest files, or do they have access by default? I believe like the internal services, like you'll have access through if you make sure they're like cluster IP type, right? But just because in your manifest file you're saying like they can talk doesn't mean they will talk. Again, you have to like develop your applications so they like your containers so they can talk, right? It's not just up to your manifest file configurations, right? And yeah, I think we got them all here.
Awesome. Well, thank you so much, Gwen. This was a pleasure, as always.
As always.
Great turnout. Yeah, great turnout. Great engagement from the chat. Thank you all for tuning in. Hopefully we got to all your questions. And take care. Have a good night.
Bye.